When we talk about fermented food, what comes across your mind? Something mushy, disgusting, slimy? Not today, people. Today we will bring you to the land of the rising sun, Japan, to undiscover the hardest fermented food in the world. Japan is surrounded by the sea, making it one of the largest fish and seafood industry in the world. Japanese are fully utilizing the fishes from making the all-time favorite sushi to the surimi, and they even make fermented fish like this, Katsuobushi, the hardest fermented food in the world. Not familiar? You've been eating it for some time. It is topped on your takoyaki or okonomiyaki and blended in your favorite miso soup. It is made of fermented bonito, a type of saltwater fish commonly found around Tokyo Bay. Katsuobushi has an ancient history. It was first made in 1674 by smoking the fish, which is called arabushi, and a century later, this method was improved by growing mold on it. There are various theories of the origin of this method. One said it was made accidentally by a merchant who kept arabushi in the wooden container during shipping, and he was hesitant to throw away arabushi that has grown mold on it, and discovered that the flavor was intensified after this incident. Raw bonito fish alone has a 25% protein content, and if used to make katsuobushi, its protein content increases up to 77%. To this day, katsuobushi remains an important ingredient in Japanese delicacies. It is used in making dashi stock, which is Japanese soup stock. It is rich in inosine, one of the compounds that give umami flavor, vitamins and minerals, including iron, niacin, and B12. It takes months to turn raw bonito ready to use katsuobushi flakes. It is started with filleting. Filleting fresh bonito into 3 pieces referred to as kamibushi. The large piece is then further split into 2 halves called mebushi and obushi that make up the honbushi. Then simmering. The blocks are placed in a woven tray in hot water, carefully arranged to ensure uniform flavor in the end product, and simmered for 60 to 90 minutes in a step known as shajuku, sealing in the inosinate. Third step, bone removal. The skin and bones are removed. The blocks are called namaribushi at this point. The following step is baikan, which is smoke drying. The namaribushi was smoked for up to a month using oak, pasania, and castanopsis wood to remove water content and prevent spoilage. The baikan process transforms the namaribushi into arabushi. Lastly, kibitsuke, which is mold application. This is the last stage of creating katsuobushi, where it allows the fish to sun-dry using the assistance of mold. The fillets are sprayed with Aspergillus species culture and left for 2 weeks in a closed cultivation room. The mold ferments the fillet, seals in aroma, and also draws out any residual moisture. Looking into the mechanism of the fermentation, the mold produces extracellular enzymes, protease and lipase, to break down the protein and lipid of the fillets. Specifically, on protein hydrolysis, the aspartic protease from the Aspergillus species can act on hemoglobin and myoglobin and change the dark reddish-brown color of katsuobushi fillet to pale pink, leading to decolorization. On the other hand, lipase activity of the Aspergillus species breaks down the triglycerides such as p-nitrophenyl butyrate C4 and p-nitrophenyl palmitate C16 into free fatty acids, which subsequently reduces the fat content in katsuobushi. The free fatty acids will then serve as the substrates for further reactions to produce many flavor compounds such as acids, alcohols, furans, and ketones. According to Kamanishi, hydrolysis of lipids during katsuobushi fermentation and ripening leads to prevention of triglyceride deposition and oil staining and improvement of preservation of karabushi. Both lipase and protease activities are high in lower water activity environments. Besides, throughout the fermentation process, the mold could transform 2,6-dimethoxyphenol into 1,2,3-3-methoxybenzene via O-methylation, which contributes to stale and musty aroma. Around 2 weeks later, the block is temporarily removed from its tub, sun-dried, and individually dusted to remove the surface mold. These steps are repeated for around 4 months. After knowing how katsuobushi is made, so what's so good about katsuobushi? According to Funatsu, the high amount of inosinic acid in katsuobushi can provide anti-aging effect, where the high energy produced by inosinic acid activates the body cells. Besides, it has a fatigue relief effect where it may improve the mood states and reduce mental fatigue, as well as increase performance on a simple calculation task. Not only that, its consumption could lower systolic blood pressure as well as level of urinary oxidative stress maker, which is 8-hydroxy-deoxyguanosine. Price! You never expect the Katsuobushi flakes we put on takoyaki is actually a type of fermented food product, right? Katsuobushi is now mainly used for processed products such as freeze-dried instant miso soup, ready-made noodle soup, and granulated bonito flavor seasonings. That's all from the Discover the Undiscovered. See you next time!